Hello everyone, I hope you are doing well and welcome to our new lesson in chain rule. So before I start our new lesson, let's remember some rules we have learned about derivatives. And I want you to help me continue these statements I have here. For an example, I have fx plus gx derivative equal to what? Who remembers this from the last week? Derivative of the sum is the sum of the derivatives. So I have to write f prime x plus g prime x. Right. What if I have minus instead of plus? What is the derivative of the difference? Exactly. It's the difference of the derivatives. Okay, what about the product? Remember this rule, we call it product rule, which says take the derivative of the first multiplied by the second plus the first multiplied by the derivative of the second. That was product rule. And finally, here we have quotient rule. What about quotient rule? I'm dividing fx over gx. My answer, how it looks like. Who can remind me how quotient rule looks like? Yeah, great. Derivative of my numerator multiplied by my denominator minus my numerator multiplied by the derivative of my denominator. Is that all? No, of course. I have to divide by what? The square of my denominator. That was quotient rule. So this is great. We are talking about the addition of two functions, subtraction of two functions, product of two functions, and division of two functions. But we have learned more operations on functions before. You remember in college algebra we studied something we call it composition. Let me remind you what do I mean by composition of two functions. And usually we use this notation, which is a little circle, to compose two functions, and we read it as f after g. What do I mean by this notation? If I want to apply this new function f after g on my input x, my answer will look like f is waiting outside, g is working inside, working on what? Working on my input x, which means first I have to apply g, and after that I have to apply f, and we call this composition. Today we're going to learn what is the derivative of the composition, f after g at x. So I'm looking for a new rule, which I'm going to call it chain rule here. And let me give you the rule first, and then after that I'm going to give you some examples to see how can I apply it in some application. F after g at x. I have to take the derivative of my outer function, which is f, when I'm applying it on gx, and multiply it by the derivative of g applied on x. I call this rule chain rule, and let me put it in a box for you. We call f the outer function, and we call g the inner function. So f after g represents the composition of two functions, as you can see. Maybe you can talk more about this rule, and I'm gonna clean everything else here. I can use it in the following examples. For an example, someone is asking me, find the derivative of the following polynomial, 3x plus 4 to the power of 5. As you can see, I have linear polynomial inside, and I have polynomial of degree 5 outside. So here I'm talking about composition of two functions. Which one is the inner function? Yay! This guy inside the linear function is gx equals 3x plus 4. I call it inner function. So good. What will happen after that? After I take my linear function gx, I will raise it to the power 5. And then I will have my outer function. So I'm going to write here, if x equals x to the power of 5 is my outer function. Since you know what is the inner function, what is the outer function, I can apply the rule I have down here. So if I want to find the derivative of this guy, and I will write it as follows, derivative with respect to x of the function 3x plus 4 to the power of 5. According to the rule I have down here, I have to take the derivative of the outer function first, then multiply by the derivative of the inner function. And let me see again. What is the outer function? We said it's x to the power of 5. But here, remember, my x, which is my input, looks like the following. 3x plus 4. I have to write my power down here, which is 5 multiplied by exactly the same guy. 3x plus 4 to the power of what? 5 minus 1. So this is the derivative of the outer function. Have we finished yet? No. We found the derivative of the outer function, but next I have to find the derivative of this guy inside. Gx is 3x plus 4. You can look at it here. 3x plus 4, what is the derivative? Exactly. So I have to multiply it by the coefficient, which is 3. And all you have to do after that is just to simplify your answer. As you can see, the last number and the first number can be multiplied together, and you're going to have 15. And here inside I have a 3x plus 4 to the power of what? 4. You're right. Let's put it in a box so it won't run away, and that would be my final answer. So this is a direct example of chain rule. And as you can see, it's so easy to apply it if you know what is the outer function, what is the inner function. Sometimes for some students it will be a little confusing to determine what is the inner function, what is the outer function. So let me give you more examples here. Find the derivative of the following. Not polynomial, but this time I'm going to take sine of x squared. So here I have a trig function. Trig of what? Of x squared. And now let's see, who can tell me what is the inner function in this case? Take a look inside. Inside here, I have x squared. That would be my inner function. So that would be my g. G is a quadratic function, as you can see. And after g, I'm going to apply what? Sine. This is my outer function, f. Now I can tell you what is the derivative here. Let's find the derivative. d dx of this guy, which is sine x squared, equal to what? Take the derivative of the outer function. So I have f, which is sine. What is the derivative of sine?
Cosine.
Cosine. You are good. So I'm going to write cosine. Cosine of what? Inside, I'm changing nothing. My gx, which is x squared, must be written again here. So I have cosine x squared. But after that, what do I have? I have the derivative of what's inside. The derivative of x squared is 2x. So I'm going to write it here. I prefer you write 2x at the beginning, multiplied by cosine x squared, because otherwise some students will think that x is multiplied by x squared and they will make it like x cubed, which is not right, of course. So it's better to write 2x at the beginning multiplied by cosine x squared. And it cannot be simplified more than this. So that would be my final answer. Now let me give you something similar but a little different. I want you to find the derivative of something so similar, and without looking at the rule, and I will give you 1 minute to think about it. What if I ask you to find the derivative of sine x squared? As you can see, it's so similar to the previous function, but pay attention, they are not the same. No, here I'm squaring my x, but here I'm squaring the sine of x. sometimes you can find it written as following. Find the derivative of sine square of x. And pay attention, the square is for sine, not for x. So, what is the inner function in this case, and what is the outer function here? In the previous example, the inner function was x squared, the quadratic, and after that I applied sine. But here, as you can see, inside I have sine x. Here my inner function is sine, and after that I will apply square. So fx is a quadratic function here. And now if I want to apply the rule, I have to take the derivative of the outer function. You see this too? I will write it here multiplied by sine x to the power of 1, and I will write it here. From where I got this one? This one is just 2 minus 1. This is the derivative of the outer function, multiplied by what? The derivative of the inner function. We already said that the derivative of sine is cosine, so I have to write it here, cosine x. So here is the derivative of the outer function, and I will write it again, f prime gx multiplied by the derivative of the inner function, which is g prime x. And this is the chain rule. And as you can see here, my answer is different from the answer I have above. If you have studied trigonometry before, you can simplify this answer more, because 2 sine x times cosine x can be written as sine 2x. It's a trig identity. So if you leave it like this, it will be much more simplified. If you want to leave it like this, it's perfect. It's correct. So do you have any questions so far?
How to tell the difference between inter and the outer?
Yeah, take a look at your input, which is here x. I'm taking the square of the x, or I'm taking the sine of the x. X is just next to the sine. I'm taking the sine of the x first, and after that I'm taking the square. So here first I'm applying the trig function inside. Sine of x first, and after you find it, I will take it and I will square it, which means gx is my inner function, and after that I will take the square, and that would be my outer function. But notice in the previous example, no, I have x, and this x is squared, so this is my inner function, which is gx, and after that I will apply the sine, and here comes fx. So gx here is my inner, and after that I take the sine, which is my outer. And you see here order matters. Why order matters? Because you know composition is not commutative. If I take f after g, my answer is different from g after f. That's why I got different answer in the first example than the second example. Here I'm applying the quadratic function first, and after that I apply the sine. But here, take a look, x is just next to the sine. I take the sine of x first, and after that I apply the square. Remember, composition is not commutative. Composition is not commutative. So composition is not like addition or a product. No, order matters. That's why I have to know which one is the inner, which one is the outer, because my answer will look different. Okay guys, I hope that was clear for you. Thanks for attending, and see you next time.